Okay, you know that what I'm going to tell you, right? Welcome to Riju and PSK online classes, another session of physics, current electricity. Okay, that's it, same thing, fine. In the last class, we discussed about meter bridge. I mean, we started with Wheatstone's bridge, then came to meter bridge. Then I was discussing about potential gradient. You remember yesterday's class, the wire, the voltage per unit, like that, everything. But today, I'll just tell you something more about meter bridge and how to do questions on meter bridge. And that's always important. You know that one. Okay. In meter bridge, whatever be the real circuit, whatever will be the real thing, that wooden plank, everything, we will not do all these things. What we do normally is that we will have a simple diagram for one resistor, and there is another for the second resistor, and this will represent that uniform wire AB. Many a times the other one is not drawn at all, but there is a battery here, and there will be an adjustable rheostat, and there will be a switch to control the current. So this is a circuit, right? And this is your uniform wire of 100 centimeter length. Now this is the midpoint. This resistance is called R. This is called S, the standard resistance. From here you have your galvanometer. And from galvanometer there is a high resistance which is not always shown. Okay, now this will be balancing somewhere here. And what are we doing by telling balancing? Balancing means you will slide over this wire so that the galvanometer current will become 0, right? Now the purpose of this high resistance in series is to prevent damage of galvanometer. That's it. Okay, but don't worry. When you are balancing this, there is no current through this resistor. When there is no current through the resistor, then there is no voltage drop. You know that one. So this HR will not affect your reading. It will not affect your reading. Okay. We will discuss more about this HR little later in potentiometer. Fine. Now, what is the meaning of balancing length? It is a length from the unknown side. This is normally the unknown thing. And you measured that from its side. This is called L, and this will be equal to 100 minus L. Normally theory, this is what we study, but understand that it doesn't matter what you call this. This resistance will be proportional to this one, this will be proportional to this one. Okay, the ratio R by S will be equal to this by that, or if you take S by R, it is that by this. But normally in the normal way we write the unknown resistance is equal to standard resistance into L by 100 minus L. S by 100 minus L is R by L. This is what we normally do. Fine. Now, in theory examination and entrance examination, variety of questions can come. Like they can ask, they can tell you what happens if you put one more resistance here parallel or one in series. So many questions can come, but whatever be it, you have to solve it using this equation. Very simple. Fine. Now, one more point is that if this resistance is not connected, parallel one is not connected, understand that when this is balanced, there is no current from this point to this point, no current. That means this point, call it as potential V1, and this point, call it as potential V2. That means V1 is equal to V2, potential is equal. Fine. Okay. Anyway, from this we will go to one question in meter bridge. Reach one question. See, we have a question here. First of all, you need to read that properly. Pause the video, read it. You don't wait for my explanation. Pause video, read that question. Okay. Now I understand that it's a meter bridge experiment. Okay. And the null point is obtained at 20 centimeter from one end of the wire when resistance X is balanced against another resistance Y. If X is less than Y, then where will be the new position of the null point from the same end if one decides to balance a resistance of 4X against Y? Okay. Now this can be solved by drawing a simple diagram, because the diagram always helps you. Okay, so there is this potentiometer wire A, B. Okay, we should take it to be 100 centimeter always, unless given. Fine. And there are two resistors here to be balanced. One is called X, another is called Y. So there is X here and there is Y here. But the condition, see, what is the condition? X is less than Y. And you should know that the length must be proportional to resistance. So if X is smaller, then the balancing length will be shorter here and longer here. That's why we get it is balanced at 20 centimeter. That means from here this is 20 centimeter and this is 80 centimeter. 20 centimeter, 80 centimeter. So immediately I understand that what is it? I understand that x divided by y should be equal to 20 by 80. 20 by 80, or this is nothing but 1 by 4. So which will also tell you that y is actually 4 times x. The value of y is 4 times x. Suppose x is 10 ohm, then y is nothing but 40 ohm. Now, what will be the new position? What is the new balancing point when one decides to balance a resistance of 4x? Instead of x, you should use 4x. So I will draw the next diagram here. This is x and you are taking y over there. This is your balancing wire AB. Now what are you doing? You are not using x, you are using 4x. But you are not changing y. Y remains same thing. Where will I get the balancing point? That's the question. Now write the next set of equations similar to this one. Now you write the 4x divided by y. This should be what? But we proved that y is nothing but 4x. So substituting that here, what you get? You will get 4x by 4x. So that should be a ratio 1. Ratio 1, it should be 1:1, equal. Equal in the sense, equal means the balancing point must be here at 50 centimeter from this side. So that this is also equal to 50 centimeter. So your answer is option A. The position is 50 centimeter. It can be asked how much you should move from the previous one. Previous one was 20, now you are moving to 50, so you have to move 30 centimeter. The slider will go from 20 to 30 like this. A good question to understand what's actually happening in meter bridge. Happy? Okay, now what is this? A meter bridge null point is found at a distance of 40 centimeter from A. The diagram is given from A 40 centimeter. If resistance of 12 ohm is connected in parallel with S here, the null point occurs at 50 centimeter from A. Determine the value of R and S. See, no resistance value is given. But from the question I understand that initially there was only S. Second case 12 is connected in parallel. So let us do that one. Okay. First balancing point is given as 40. So with the R and, we'll take a good color. With R and S alone, the balancing length was, this side was 40, this side will be equal to 60. So that is equal to 40 divided by 60, which is nothing but a 2 by 3. R by S is 2 by 3. Now, you are putting something in parallel here. So let us say when you put this in parallel, let me call this as S dash. And what is S dash? S dash is nothing but 12 parallel with S. That is S dash. Now you are not changing R. You are taking this is the first case. The second case, you are taking R divided by S dash. And what is given? The null point occurs at 50 centimeter from A. Instead of 40, you are getting it at 50. So the remaining length will also be equal to 50. That means this is the ratio 1. So that means you know from this one you will get the value of S. From this you will get the value of S dash, and I can actually go for that equation. Fine. So what you get? You get here S dash is equal to R. S dash is equal to R. Fine. And S dash is equal to R. And what is S dash? S dash is the parallel of 12 and S. And here we get S. What is S from the first equation? See, from here we will get S is equal to 3R by 2. This is equation 1. This is equation 2. Now I will write what is S dash? S dash is S parallel to 12 ohm. And let's write the equation, parallel connection. 1 by S dash is nothing but 1 by S plus 1 by 12. Fine. Now you can solve it. This will give you 1 by S dash. S dash is nothing but R. 1 by R equal to 1 by, what is 1 by S? 1 by S is 2 by 3R. And this should be cleared. 1 by S, you can see S is 3R by 2, so 1 by S is nothing but 2 by 3R plus 1 by 12. Now we can say this is 1 by R minus 2 by 3R is equal to 1 by 12. What is 1 by R minus 2 by 3R? That is 1 by 3R. So you will get 1 by 3R is equal to, right, 1, 3 minus 2, 1 by 3R. This is nothing but 1 by 12, which tells you that 3R is equal to 12, which tells you that R is equal to 4 ohm. Initially, the value of R was equal to 4 ohm. So we get R is equal to 4 ohm. And what is, you want both R and S in the question, right? So what is R? R is equal to 4 ohm. What is S? You have S here. What is the equation for S? I'll write S is equal to 3R divided by 2. And that is 3 times 4 divided by 2. So you'll get 6 ohm. So we get R equal to 4 ohm and S equal to 6 ohm. Now you can test whether this will be okay. If R by S, R is 4, S is 6, you get the same ratio, 4 by 6. So that is it. Your answer is right. So this is how you solve it. Fine. Practice this. This kind of questions were asked many times in board examination too. Okay, not only in entrance, board examinations. Fine. Okay. In the previous class, we discussed about potentiometer. I said potentiometer is a device which can measure EMF, compare EMF of two cells, and it can also measure internal resistance of a cell. Fine. And potentiometer has got a very long wire, around 10-meter wire, and it is like in the form of different loops. You'll understand when you see actual diagram of the device. Fine. Now, in a potentiometer, the principle of operation of a potentiometer was this. I said in a uniform wire, potential gradient is constant. The potential difference between any 2 points depends on the length between the two wires. That's what we said. I did a couple of questions in the previous class. Just rewind that one. Fine. Now today we are going to study what is the actual circuit, potentiometer circuit, and how does it work and how to do questions on that. Fine. A potentiometer has got two types of circuits. One is called primary circuit, another is called secondary circuit. This theory is not important for your board examination. In board examination, they will not ask you what is primary and secondary. Don't worry, but this is to understand. Fine. Now, it has got a primary circuit as well as a secondary circuit. Roughly, I'll explain all this later. This is the primary circuit. There is a cell, there is a variable resistor, a key, and a uniform wire AB. A uniform wire AB is also connected. Naturally, when the switch is closed, a current will flow through this, and that current will create a potential difference between A and B. Okay? If you divide that potential difference by length of the wire, last class will give you potential gradient. That is the purpose of the primary circuit. What is the purpose of primary circuit? Primary circuit is to create a potential gradient in the wire. You have a wire, you need a potential gradient. For that, you need to pass a current. That is done by this cell. Fine. Now, the secondary circuit is where you put the cell whose EMF should be calculated. So this EMF you already know, but this one is a cell under a test. You have to find the EMF of this cell. In the practical examination, they will ask you what is the EMF of this cell. Then this is connected in the secondary circuit. And in the secondary circuit, what do you see? You will see the cell and the galvanometer and the high resistance in series. And why high resistance? To protect the galvanometer, no other purpose. This high resistance will never come in your calculations. So that's why its value is not given. So this is the primary circuit, and the total potentiometer circuit will be the combination of all this. This is the total circuit. So see, the positive of the cell under a test and the positive of the primary cell both are connected to point A. That's an important point. Right. Now, the circuit is completed. And the procedure is very simple. You have to rig your circuit like this. Once you rig the circuit like this, what you have to do is that you will have to take the jockey and touch at A. You touch the jockey at one end. Then your galvanometer will show deflection in one direction. Then take the jockey and touch it at the other end B. Then the galvanometer should show a deflection in the opposite direction. Then your circuit is correct. Because only when left and right deflections are opposite, somewhere along the line in between, you will get zero deflection. Manasilayo. Suppose you get a leftward direction at A as well as B. That means nowhere in the wire you will get zero. If you want 0 somewhere along the wire, 0 reading of galvanometer somewhere here, just like in meter bridge, then AB deflection should be opposite. This is the first test that you do after rigging the circuit. So now, now what is the working? How does it? What is the procedure? Procedure is simple. After testing everything, you will just move this jockey. You will move the jockey over the wire. You slide it over the wire till your galvanometer will read 0. That is called null deflection. At that null deflection, you will measure this distance, this length. That's called balancing length. The test is very simple. The experiment is very simple. Okay. Now the theory behind that. Oh, from my last class, you should know that when this potential difference and when this potential difference are equal, that's why there is no current flowing. I told you this in the last class with sufficient details. Now, in one NEET examination, there was one question similar to this one. Okay. And last year itself, I know many students came to me during their board examination telling that they don't find it easy to understand. But with my help, it was very easy for them little later. Okay. I am not taking the credit goes to the student, but I just told them how to approach it. So I am telling you that in advance. Do not come to teachers just before your board examination asking for potentiometer. So you have to study this carefully. And these equations are not for your board examination. This will not be asked. For board examination, that's very easy. You can directly give answers. But for entrance, they can test you in depth, especially in JEE mains and advanced. Let us take the primary circuit of the potentiometer. This is the primary circuit. In the primary, I have added more details. More details in the sense, in no way a tester should beat you. Okay. There is a primary cell, and the primary cell will have a resistance inside. It's called internal resistance RP. Internal resistance of the primary cell. Fine. RH is the resistance of the rheostat. RH, rheostat. K1 is the key in the primary circuit. There is a wire here, and the wire has got a length L, and RW stands for the resistance of the wire. So when you look at the circuit, there are 3 resistors, which are the RP, RH and RW, and all of them are in series. So once you close the circuit, a current will flow. What is that current? How to calculate current? Current is calculated as the EMF of the primary cell divided by the total resistance. You can see that one here. So this part, what is this part? Just check whether you know that one. What is that part? What does that represent? It is the EMF of the primary cell divided by all the 3 resistance in the wire. So this gives you the current in the primary wire, and the current will flow in this direction, telling this is positive potential, this is negative potential. If I multiply that current by resistance of this wire, this current into RW, RW is the resistance of the wire, what will I get? I into R gives you potential difference. Between which point? Between the point A and B. Fine. Now if I divide that potential difference by length of the wire, I'll get this term. Once more, this is the current in the wire, and current into RW, potential difference across AB, divided by length gives you potential gradient or potential drop per unit length. In NCERT, they use the word potential drop per unit length, but I use the word potential gradient, phi. So phi is calculated. Stop the video. When I said stop the video, my cameraman stopped the video. That's happened. Okay, now please. Okay, now stop the video and write potential gradient by yourself. Write the potential gradient by yourself. Fine. Now you know the potential gradient, which is potential difference per unit length for the whole wire. Now what is the potential difference between A and J? What is potential difference between A and J? We know potential difference is nothing but potential gradient into length. Last class I told you like Vaj equal to phi into Laj, and this Laj is marked as L in my diagram, and the potential gradient is calculated. So what is the voltage between A and J? This is very crucial, my children, very crucial, very important to know this. Okay, what is the potential difference between A and J? That is nothing but phi into L. EP by RP RH plus RW into RW by L into L. There are two L's here. One is the balancing length and another is the total length of the wire. In the practical examination, you don't have to calculate this, but for entrance, you need to know this. So I get VAJ. Is that part okay? So the primary circuit, this is what you have to study. In many questions, they may not give you internal resistance. They will say there is no internal resistance, then put RP equal to 0. Sometimes this resistance will not be given, then put that that also 0. Then you work out. One test, what is that test? Suppose you have a cell connected directly like this one. There is a wire 2 meter and there is a voltage 3 meter. No internal resistance, nothing is given. What is potential gradient? Here potential gradient as per our equation is E. E is given as 3 volt divided by internal is not given. Rheostat is not given, but the wire definitely will have some resistance. Let us call this RW, then plus RW bracket into RW divided by L. So that gives you this RW will cancel. So that gives you 3 divided by L, and 3 divided by length is given as 2 meters. That's simple. Fine. In many questions, this is what you need to expect. Okay. Now, once this part is okay, if this part is not okay, stop video, go and sleep. Come back a little later, study. Without this, do not go forward. Okay, Pakka. Now I am taking the secondary circuit where you have the cell under a test. And the cell will also have an internal resistance R. And there is galvanometer. The galvanometer will also have some resistance. And there is a series resistance. Fine. Now, assume that there is a current here. If you assume that there is a current here, this current here, and this current will go through the galvanometer. So I will call this current as I galvanometer, which will flow through the cell, its internal resistance, galvanometer, and the high resistance like this. Okay. Now you see this switch. If I close the switch, what will happen? If I close the switch, the current will flow like this. It will not go through the high resistance if I close the switch. But normally this is kept open, so that will go through the high resistance. Now you have an EMF and this many resistors. So what is the voltage available for you? Use the idea of a discharging cell. The voltage available between A and J, VAJ, is the EMF minus drop in internal galvanometer and high resistance. Getting this? The voltage available here equal to EMF minus drop in 3 resistors. Which are they? The internal, galvanometer, and high resistance. That's it. But we know that when we balance the potentiometer, galvanometer current is going to be 0. Okay. So we know that when balanced, galvanometer current is 0. So what? So the second part here will become 0. So we will get a VAJ equal to E. Suppose the cell has got an EMF of 7 volt, then here you will get 7 volt because there is no current. Galvanometer current is absent. So when the galvanometer shows you 0 reading, the 7 volt will be directly available here. Wow, wow, beautiful. Understood this? Understood this? Now previous one. In the previous slide, we know the voltage between these two, the voltage between these 2 points is given by this equation, VAJ. But that is from the primary circuit. From the secondary circuit, we understand that if there is no current through the galvanometer, then VAJ is equal to E. I told you we combine these 2 things. When we combine these 2 things, you get the whole circuit. Now imagine you are doing the experiment. You move your jockey from A to B so that galvanometer reading 0. If galvanometer is reading 0, the VAJ from the secondary circuit is equal to EMF of the cell. And VAJ from the primary circuit should be equal to this equation. What is the meaning of galvanometer reading 0? Because that voltage and this voltage are equal. That is again from the last class. I gave you that idea of 2 water tanks. So when the potentials are equal, no current flow. So we can say when balanced, the EMF of the cell is equal to this thing. This is what you need for entrance, and for board examination you don't have to worry. You simply write E equal to, what is this called, phi. Phi into L. E equal to phi into L, and NCERT, if you read NCERT, you should read NCERT. In NCERT, they write that E is equal to phi into L, where phi is the potential drop per unit length, and that's our potential gradient. Or we can say E proportional to L. Why? Because phi is kept constant. That's all. The past 5 minutes will teach you potentiometer to any extent of entrance examination. That is sufficient. It's my guarantee. Okay. So when balanced, this is what you need to remember. E is proportional to L. Now let's come back to the complete experiment. If you see the NCERT diagram, that's quite different. Not like the one I have been using. In NCERT, you can see this actually is a long wire. They said the wire is in couple of folds, different folds like this. There is this B is for battery. This is my primary cell. This is the rheostat. This is a K1. And this, in my diagram, the wire was AB, but here it is AC. The wire is AC. And the galvanometer is connected here. And you see an odd kind of a switch. If you closely observe that switch, you will understand that it has got multi-purpose, multi-function. If I put a wire between 1 and 3 like this, then you can see the cell E1 is connected to galvanometer. But if I connect that to 2, that will connect the second cell to your circuit. So this can use, this switch is useful in connecting 2 cells alternately, that and this. Okay. But I will make it a little more simpler. Instead of showing this multiple folds of wire, I will just use my straight wire. Now what you have to do is that face the screen, turn your head rightward 90 degree. Look like this, then you will see your diagram. Okay, so this is the same thing. Fine. Now let us go to our diagram. Our diagram is like this. Balancing length E. Okay. Now the purpose of high resistance is to protect a galvanometer. And how does that work? Suppose you take the jockey to the side A. See, somewhere here current is 0, but if you move towards this side or that side, what happens? Current will increase. And if the current increases beyond certain value, the galvanometer has a problem of overheating and burning out. You will know only when the smell comes, and you will lose one galvanometer. You need to prevent its damage, so you put a high resistance. Fine. And now when you reach the balancing point, in the previous diagram I have shown you a switch across the galvanometer, across the high resistance. There will be a switch across this thing. So when you reach the balancing length, what you do? You will close this thing. That will remove high resistance from the circuit, because current will not go through the resistance, that will go like this. But that will be done only when you reach the balancing length, because at that point current will be less. In the beginning you should not do that one. Okay. Why is this not getting erased? Okay. Now the experiment is simple. First you will close the switch K1, a current will flow, a potential gradient will be created. Then you will slide the jockey till you get the balancing length, and you will know that E is equal to phi into balancing length, or E proportional to L. That's it. Now you can use that multi-switch. You can introduce a next cell. This is for the first cell, you will get L1, first cell L1. Do the same thing for the second cell, you will get the second balancing length. Then you take the ratio, you will get E1 by E2 is equal to L1 by L2. If you know one EMF, you can calculate the other EMF. Otherwise, you can get a ratio. That is the working. Just read NCERT. Okay. Now, to compare EMF, I will just explain that using NCERT diagram. Okay. Suppose I connect this part, this one, like this. If it is connected, then E1 will come to your circuit. Okay, so I'll get E1 proportional to its balancing length L1. Then I will disconnect that. I'll connect this to 2. Then I'll get the E2 proportional to its balancing length L2. Then I can take ratio E1 by E2. Is that okay? I think that is sufficient for potentiometer. Now you are ready. See this question. Read this question completely. Stop the video, read this question completely, try to understand that one. Okay, what is given? There is a 3 volt cell in the primary circuit. It's also called driver cell. Sometimes it's called driver cell. And in the secondary circuit, there is a 1.5 volt thing. And this is balanced. This is balanced at 60 centimeter. So that is a very direct one. We know E1 proportional to 60 centimeter. And it is given that that is replaced by another cell and the balancing length is given as 80 centimeter. So we get E2 proportional to 80 centimeter. You want to find out the unknown EMF. The second one is unknown EMF. So we know that E2 divided by E1 here is equal to 80 divided by 60, which is nothing but 8 by 6, which is 4 by 3. Now you want E2. E2 should be equal to 4 by 3 into what is E1? E1 is given here as 1.5. So that is 6 by 3, which is equal to 2 volt. Fine. So you got the answer for the first question. Now explain with reason whether the circuit works if the driver cell is replaced with a cell of EMF 1 volt. Okay. If you replace this by a cell of 1 volt, then it cannot produce a balancing length here, because to produce a balancing length, the EMF of the driver cell must be greater than the EMF of the cell under test. Otherwise, the balancing length will become more than the length of the wire AB. So the length of the wire will be 1. Okay. Now that will become more than that one. How do we calculate this one? That's by calculating the potential gradient. So understand that the cell under test must be always smaller than the cell in the primary cell or the driver cell. So that is not possible. Last one, does the high resistance R used in the secondary circuit affect the balance point? Justify your answer. I told you there is no current through this thing during the balancing condition, so that will never affect. See, once it is balanced, whether you increase or decrease this high resistance, that will not affect the balancing point. So this kind of question are asked in board examination. Don't worry, in the NCERT textbook at the end you have large number of similar questions. Work out them, because most of the board examination questions are picked from that one. Not the question, but the idea. Okay. There is another use of potentiometer, that is to measure the internal resistance, and we are going to discuss that one. Watch these two circuits. This is the one we have been discussing so far, and now I have altered it here. What is that alteration? What is additional here? You can see that there is a resistance R here and there is a switch. There are two switches here. There is only one switch here. Fine. Now during balancing there is no current like this. There is no current. That's why you get EMF. You remember that. But here, if you close this switch, what will happen? If you close this switch, what will happen? A current will flow from the cell like this. The cell will be in the discharging mode. Here the cell was in the open circuit mode, but here it is in the discharging mode. So when it is in the discharging mode, what will happen? The available voltage will become less than its EMF. We call it as a terminal voltage. So whatever you are balancing is not EMF, it is a terminal voltage. I'll explain it. Watch out. This is the secondary circuit for our circuit. Secondary circuit, the connections are different. The cell under test, its internal resistance, galvanometer, high resistance, but there is an additional resistance here. Right. Now, when switch K2 is closed, when the switch K2 is closed, what will happen? When the switch K2 is closed, what will happen? A current from the cell will flow like this. I will call this as current in the cell, I cell. Okay, now a current can even flow through the galvanometer. I can call it as current in the galvanometer. There are two currents now. One current through the cell in the outer circuit, another is current through the galvanometer which goes to this wire. What is potential difference between A and G? What is potential difference between A and J? That is E minus a drop in here, okay, minus drop in these two resistors. Okay. Now, normally this E minus I cell into R, the total current in the circuit, I mean, this is not I cell, this is I cell. The total current in the cell minus the drop, this is E minus the drop in the internal. This is what we call as terminal voltage. Fine. So, terminal voltage which is available at this point, E minus that is available here. From that again drop in these two resistors. So, V minus Ig into Rg plus Rh. What is Rg? Galvanometer resistance, and what is RH? That is the high resistance. But when the cell is balanced, when the bridge is balanced, the current through galvanometer is 0. So what will happen? This Ig into Rg plus Rh will become 0 and we will get Vaj equal to V. That's what I said. If the switch is, listen carefully and study this, if K2 is open, you will get EMF here. If K2 is closed, you will get a terminal voltage. So my question is this, what is Vaj? So you should have two answers, that is E or V. When K2 open and K2 closed. Analyze and study. What happens when K2 is closed? When K2 closed, there is a current in the cell. If K2 is open, there is no current in the cell. If K2 is open, cell is in open circuit, K2 closed, cell is discharging. Fine. If you know that one, the next part will become easy. Measurement of internal resistance of a cell. This is the circuit. Everything is rigged up, the connections, everything is made like this. Okay. Now what? The key K1 is closed. Tang. What will happen? A current will flow, potential gradient will be created in the primary circuit. K1 is closed. Right. Now, you can adjust the rheostat for proper current, everything. Keep K2 open. Means this cell is an open circuit. That's to get EMF. Slide the jockey, get the balancing length, and then you can write E proportion to L1. K2 open means open circuit. Remember, K2 open circuit means EMF proportion to L1. Now, close K2. Now suitable resistance R is inserted here and K2 is closed. When K2 is closed here, the voltage available here will become less. And when it becomes less, then the balancing length will also become less. Okay. You will get a new balancing length L2, which is actually V proportion to L2. V is the terminal voltage. I think it's okay. Watch this again. Okay. Now, we know E by V will become L1 by L2. And once upon a time in your life, you studied an equation for internal resistance. During the EMF terminal voltage discussion, I gave you this equation that internal resistance is equal to E minus V by V into R, where E is the EMF, V is the terminal voltage, R is the external resistance. And using that one, you can say R equal to L1 by L2 minus 1 into R. That's it. So if you know the operation of potentiometer very well, this part is again easy. So potentiometer can be used for measuring EMF, comparing EMF, and measuring internal resistance. In internal resistance, circuit is slightly different. There is a second circuit here, a third circuit here. Keeping K2 open, you get EMF. Keeping K2 closed, you will get terminal voltage. That's it. Are you sensitive? If you are sensitive, you will show a large emotional change even for silly reasons. Small reason, big emotions. A potentiometer can be sensitive if it can measure very small voltage and it can show very large balancing length. For small voltage, large balancing length. That's what make a potentiometer sensitive. Remember, the balancing length, if it becomes very small, measurement will be difficult. Suppose the balancing length is like 0.1 millimeter, taking reading will be difficult. But if it is like 60, 40, 90, etc., it's easy. So a potentiometer becomes sensitive when it can measure small voltages and give you large values of balancing length. Okay. So the definition is here. The sensitivity of a potentiometer is defined as the smallest potential difference that is measured using the potentiometer. Now, see this equation. We know EMF is balanced against the length L. and length, balancing length, you can see it is inversely proportional to the potential gradient for a given cell. Balancing length. So, if you want to measure a smaller value and you want a larger balancing length, then you must know that phi must be small. When phi is small, you will get large balancing length, right? And what is the definition of phi? Phi is given by potential difference across the wire by length of the wire AB. Okay, so if you want phi small, you can see phi is inversely proportional to length of the wire. Not a balancing length, this is length of the wire, this is balancing length. So if you read this together, a sensitive potentiometer should have a very low potential gradient and it should have a large length. Increasing length of the potentiometer wire is a method of increasing sensitivity. That's why you have 10 meter wire instead of 1 meter wire. Now you got the idea. Why 10 meter wire? So what happens if I make it 20 meter? Its sensitivity will increase. Board examination point, board examination question. Alright. One more point. Potentiometer is called ideal voltmeter. You know why? Because during the working of potentiometer, is there any current taken from that cell? No current is taken. But whatever be a voltmeter will always take some current. So when voltmeter takes some current, what happens? There is a change in the voltage of the cell. Because the cell will become discharging and the EMF will decrease. You can't measure EMF using a voltmeter, but you can measure EMF using a potentiometer. That's why potentiometer is called an ideal voltmeter. Why is it called ideal and what is the difference? Because it doesn't draw any current when null point. This was asked in NEET examination. Why potentiometer is called ideal voltmeter? Read this reason, study that, think about it. Okay. So we have completed all the measuring devices, Wheatstone bridge, meter bridge and potentiometer. Now we'll see in the next class. See you. Tata.